The last topic we will cover in Part A of Week 1 is data representation. So data representation is essentially the way all this data that we have in our code is stored in the physical components of the computer, in the computer's hardware. So the basics of data representation is that every piece of data in your code is stored on the computer as a sequence of zeros and ones. Alright, that's why everything on a computer, zeros and ones. Reason being, electronic components, which are namely the things that make up your computer, all the different chips and stuff part of it, all electronic components have two states, either on or off. This is a little bit of a generalization, but essentially each component, it either has an electric charge currently or it does not. So the on represents a 1, the off represents a 0. So again, keep this in mind. Keep in mind the fact that every piece of data is stored as a sequence of zeros and ones as we talk about how the data types are stored on a computer. Some unit information for you. So a bit is the smallest unit of storage for data representation. So a single 0 or 1, that is what we call a bit. Bit is short for binary digit. We will talk about binary numbers this week, so that's something to look forward to in Part B. A byte is 8 bits. The way I keep those two in track is if I'm going to take a byte of something, I'd rather have more, right? So a byte is the bigger one. Byte is 8 bits. A bit is a single 0 or 1. So you may have heard this terminology before if you're looking at the specs of a computer's memory. So some terms you might have seen are kilobyte or KB. That is about 1,000 bytes, which means that is about 8,000 bits, right? Because there's 8 bits in a byte. Megabyte is about 1 million bytes. Gigabyte of storage represents about 1 billion bytes. And a terabyte, which is what some memory now is has come to, is about 1 trillion bytes. So if you think about a storage disk that has 1 terabyte of storage on it, that means it can store 8 trillion zeros or ones on it. So these are all the cool storage units that you might have seen in your computer specs. Alright, so again, since everything stored in a computer is stored as a sequence of zeros or ones, that means any piece of data that's stored in computer's memory must also be stored as a sequence of zeros and ones, right? So a sequence of zeros and ones, that can also be referred to as a binary number. Again, we will talk about binary numbers in Part B, but for now, a binary number is essentially a number where all the digits are either 0 or 1. Binary means base 2. Again, we'll talk more about binary numbers in Part B. But for now, just keep in mind any piece of data that's stored in a computer's memory has to be stored as a binary number. So to store numerical data, such as integers, floating point values, complex numbers as well, those are stored as binary numbers. The conversion for doing that, it's not actually too bad. You essentially take the base 10 decimal number as we know it and convert it to base 2. That said, we are going to learn how to do that conversion, and we will do that in Part B. So stay tuned for that. With strings, though, there's this extra step. So when a character, and again, strings are sequences of characters. When a character is stored in memory, you first have to convert it to a numeric code. So again, the goal here is to eventually represent this character as a sequence of zeros and ones. So for each character, you first convert it to a numeric code, and then you convert that numeric code to a binary number. So there are a couple different standards for how these characters and numbers match up. That said, the most commonly used system to represent characters as a numeric code, at least here in the US, is called ASCII. That is short for the American Standard Code for Information Interchange. So again, this is a way you can convert each individual character of a string into a number, so then that way you can convert that number into binary, into a sequence of zeros and ones. So I do have a table posted on Canvas that links you to this page here. This table essentially shows you what the numbers are for each character. I specifically want to point out capital A right here. So capital A, the numeric ASCII code for that is 65. So you can see capital B, 66, capital C, 67, and so on. And then lowercase a is over here. So lowercase a, its ASCII numeric code is 97. Lowercase b, 98, and so on. There's also other characters on here as well, characters with accents, symbols, all that fun stuff. That said, for this class, for ASCII, you should know one, sort of the point of ASCII, what it is, what it does, why we need it, and two, you should know the ASCII values for capital A through Z and lowercase a through Z. Alright, now it may sound like a lot, but you really only have to memorize two, right? Because I showed you on that table, capital A is 65, which means capital B is 66, capital C is 67, and so on. So for all the capital letters, just memorize that A is 65, and then you can figure out the rest of the letters from that. Same thing with lowercase a. Just memorize that lowercase a is 97. From there, you can figure out, alright, that means lowercase b is 98, lowercase c, 99, and so on. So again, for this class, you should understand sort of the point of ASCII, why we need it to represent strings, and you should know the ASCII values for upper and lowercase standard A through Z letters. You don't have to worry about any of the special symbols, you don't have to worry about letters with accents or any of that stuff. Alright, that said, if you have any questions about data representation, please let me know, either post to the discussion forum or send me a direct message on Canvas. And part B for this week is going to be all about binary numbers. So get excited for that, it's a pretty cool topic, and I will see you all then.